from the high desert and the great American Southwest. I bid you all good evening, good morning, good afternoon, wherever you may be in the world. And it is a big one with time zones stretching all the way around until tomorrow. I'm Art Bell, and this is a program called Midnight in the Desert. And it is so because, well, of our theme song, of course, and also the fact that when we're doing it, it's always midnight somewhere across the U.S. Just sweeps across. So here are the rules for the show, and they are very simple. No bad language, and only one call per show. Let me do some thank yous. Telos, Joe Talbot, thank you. Keith Rowland, my webmaster. Heather Wade, producer. Stream Guys, of course. I know you love it when they do their ad. LV.net, sales, Pete Eberhardt. TuneIn Radio, naturally, since they get it out there. And Leo Ashcraft, who is our Dark Matter News guy. Okay. Have you ever had something that just really gnaws at your soul? And I don't know why this is gnawing at my soul, but I'm going to bring it up again tonight because it's doing that. If I have a soul, it's definitely gnawing at it. Otherwise, it's gnawing at whatever we call a soul. According to the Inuit elders, the earth has shifted. This is not a minor matter. It's a new warning that comes to NASA from the Inuits. They are warning the change in the climate that we are experiencing has nothing to do with global warming, but rather because the earth is shifting a bit. Now, so far I'm not worried, right? But it goes on. The Inuits are local people that live in the Arctic regions of Canada, the U.S., and Greenland. They are excellent weather forecasters and always have been, and so were their ancestors. Presently, they're warning NASA, because I guess they want NASA to look, that the cause of a change in weather, earthquakes, so forth, not due to global warming, as the world thinks, but they say we have shifted or wobbled the whole Earth. Now, here's where it gets worrisome to me. This is what's gnawing at me. They say, and this is in quotes, their sky has changed. The elders declare that the sun rises at a different position now. Worrisome. Not where it used to be previously. They also have longer daylight to hunt than they used to have. Sun is much higher than earlier. They say it gets warmer much quickly. Other elders across parts of North America also, or the entire North actually, also confirmed the same thing about the sky changing when interviewed. They also allege the position of the sun, moon, and stars have all changed for them, causing changes in all kinds of things. Now, this has affected even the wind, they say. It's very difficult to predict the weather now, according to them. But I don't know. When they say that their sky has changed, that actually, it really gnaws at me and worries me a lot. By the way, not that I think anything is going to happen in September this month, in 5 days or whenever people have been saying. But you remember I told you there was this generation going on, this generation of worry on the Internet about September? And it was funny because when I said it, I guess it must have been early. I caught it early because people came and said, come on, what are you talking about? I looked on the Internet, I don't see anything. Now it's like a tsunami, an absolute tsunami. So I don't know. People are saying, all right, you've got to have somebody on about what's going to happen in September. I don't know what that would be, unless CERN is going to do an experiment. I don't think they are. They might. Create a black hole. Eat us all. I don't know. Anything else? Well, the government exercise is going on, I guess. And then there's this moon thing. I don't know. People, they've always got to have something to talk about, right? So now it's September. Okay, so Arizona, nastiness, sign of the times, somebody taking pot shots at vehicles on I-10 in Arizona. What the hell's going on that people would sit there with a rifle and take shots at cars, shattering windows and stuff like that? One 13-year-old hurt by a shattered window, and eventually somebody will die, of course. Crazy. We have Russian troops now in Syria. Wonderful. Just wonderful. Russian troops. It is beginning to feel again like the Cold War. Every day it gets colder and colder. Now there's a climate change for you. Every day the Cold War gets colder. Or what should have been the warming gets colder. I don't know what I'm talking about. Then finally this. A squeeze down a narrow crack, and then an amazing, amazing discovery in South Africa. Jagged rocks hooked into Stephen Tucker's overalls as he squeezed down a crack deep in a subterranean cave, and upon emerging the other end, he saw he was in a chamber dripping with stalactites. Then his headlamp shone on a bone, then more bones, and half a skull. It was the night of September 13th, 2013, and Tucker and his caving partner had just discovered the remains of what scientists would later determine to be a new member of the human family tree. They think about 2 million years old, and they did, a kind of a reconstruction of what it would have looked like. And I must tell you, if accurate, it's half human and half monkey. Ape. It really looks as much ape as human to me. And if it is what it appears to be, it's another blow for creation, and certainly a big star for evolution, right? Okay, coming up in a moment, this is going to be, I guarantee, a very interesting evening. Professor David Paris is president of Space Warp Dynamics, LLC. This is a newly formed company that is conducting research and development of the first functional space warp motor. That's right, I said space warp. David also teaches as an adjunct professor at the University of Nebraska at Omaha. He teaches astronomy, meteorology, geography, and geology. He has also taught college physics for over 6 years. So, I want to see something very quickly. Somebody on my Facebook said that I talk about audio for, must be 40 minutes every hour, so I'm going to time myself right now. If you want to sound better, here's how you do it. If you have a iPhone or whatever you've got, doesn't matter, download Skype. It is free, absolutely free. When you get Skype, go to add a contact. It's a little plus sign. And you can call us for free on Skype from anywhere in the world. North America, you would simply put MITD51 in, and then we'll appear on your contact list, and you can call us, MITD51. If you're outside the U.S., anywhere else, MITD55. All right, let me stop this. Okay, so sound talk was 33.65 seconds. So the person who wrote that I spend 40 minutes an hour talking about that is dead wrong. Now, if you'll just stay where you are, in just a moment, we'll come back with Professor David Paris, and we're going to be talking warp drive. So, Scotty, prepare to move the levers forward.
I'd like to know, 'cause here I go again.
The clock strikes 12, and Midnight in the Desert is pounding packets your way on the Dark Matter Digital Network. To call the show, please direct your finger digits to dial 1-952-225-5278. That's 1-952-CALL-ART.
Well, all right, here we go. Professor Paris, welcome to Midnight in the Desert.
Thank you, Art. It's good to talk to you.
Yeah, it's great to have you here. Look, If I saw this in a newspaper headline somewhere, warp drive invented, I guess probably I would, think of Star Trek real quick and then chuckle to myself, and I would expect to find it on one of those websites where, I don't know, they talk about, human women having alien babies and stuff like that. I mean, it's pretty wild stuff, right?
Of course. It's definitely outside the box. That's for sure.
Way, way outside the box. All right. Let us begin. There was, I am told, 45 seconds that changed your life, Professor.
Correct.
What was it?
I was up at Goodyear Lake, upstate New York, and near the end of August, 1969, and saw a silver disc come over the mountain. And when it passed our position with several other kids there, it banked, righted up, and then it just went. And ever since that time, it has stayed with me. And the fact that I have always wanted to replicate what I saw. And so I guess since 1969 to now, I've been working on that concept. And
well, Professor, before we go on, you and I share something. I had my own sighting, and it was a beaut. Couldn't have been more than 150 feet above my head, a gigantic triangle that blanked out the moon and the stars and sailed right over me, directly over my head. If I hadn't been in such shock, I probably could have thrown a rock at it or felt like I could. It was that big. Went out across the valley and kept going. And pardon me?
And it left a definite impression on you.
Oh, God. Impression, it changes your life.
Yes.
This thing was not flying. It was doing maybe 30, 35 miles an hour. It was floating or defying gravity. It appeared to be metallic, so I would say defying gravity. And yes, when these things happen, of course they do. They change your life. How can you ever be the same?
You can't. And with mine in particular, it was going about 20 miles an hour. It was about 500 feet off the ground and about 1,200 feet downrange from us. And I was at 16. I was taking flying lessons at the time, so I knew when you bank an aircraft, you're going to lose altitude, and unless you got a missile, and even then, you alter the orientation of the aircraft, you're gonna drop a bit.
Well, yeah, there's a altitude speed trade-off, right? When you do that.
Oh yeah, absolutely. And this thing was about 60 feet in diameter, and had about a 12 or so foot girth to it. It was a saucer. It was silver. But the thing that caught my interest the most was that there wasn't any sound, there weren't any smoke, there weren't any greenhouse, in other words, glass.
Same with mine, by the way. I could hear crickets a quarter mile away while this thing passed over.
And this was early morning, absolutely quiet against a blue sky, no clouds, sun to our back.
Right.
And when it banked, you could see the striations in the metal. There actually appeared to be a front, a back, side to side. But when it banked, it never lost any altitude. And that was the thing that fascinated me. And then it righted up, and then the thing just went from the 20 miles an hour whoosh, right out of sight.
Well, of course, as you described it, Professor, it wasn't flying anyway. In other words, it didn't have air over wings, right, at all. So,
well, the only thing that you could detect, there appeared, and this was later on when I was flying gliders, is that sound of air buffing over the cockpit.
Sure.
All right?
Sure.
That's a very unique sound.
Yes.
And with this craft, as it came over our position, you could hear a very, very, very slight air buffing as this thing went through the atmosphere.
Sure. It was displacing air, so yes.
Uh-huh. But the driving force on that was to try to replicate how that thing flew and what kind of propulsion system that it had. So that was the thing that fascinated me. And I was always involved with, football and wrestling and sports, and all that. And I dropped everything right after that sighting, and I just started to concentrate on the sciences and engineering and throughout my career. So it's all been that definitely did affect me in my direction of which I took in life.
Obviously so. You became involved with MUFON, for one thing, right?
Yeah, I'm the state director of Nebraska. Just was appointed that position. Dr. Jack Casher just retired from the organization after 25 years. I mean, he's still a member, but I mean, he stepped down as state director.
Let's talk about MUFON a little bit. You probably know Peter Davenport. I interview him regularly, right?
Yes. Look at his site on a regular basis.
National UFO Reporting Center. He and I had a discussion about the number of UFO reports compared with, I don't know, from the mid 40s on, and whether it's actually dropped in recent years. Do you think it has?
Our records indicate that the sightings, at least in Nebraska, have gone up.
Okay.
More than they have gone down.
You thought so, too.
But again, we get a lot of reports in and around the holidays, particularly like 4th of July. So these lanterns that people like to launch, people misinterpret these as being some type of craft. But lately we have been getting a lot more than we have noted in the past, say, 10 years.
I was talking to Peter, and I'll tell you the same thing. I confess I am a drone owner. And it is possible, unfortunately, to dress up a drone with LED lights. And I'm telling you, by the time you're done with it, if that thing doesn't look like a saucer, you didn't do your work right.
And that's one of our biggest problems that we have in addressing these cases that we get assigned. Is during the investigation, the people are only reporting what they see.
Sure.
Then you have to then analyze exactly what they're talking about and the position in the sky relative to this. And most times, and this is the sorry part of it, most of these observations are at night. So you have no absolute reference to ground or a tree or a building. Many times it's just against the black sky. So, most of these things go reported as unknown. And it's kind of a shame in a sense, because when you introduce the hoaxing that comes in with the drones, photoshopping, I mean, we've developed a set of software. It's a fractal analysis, actually, that will analyze photos. And if they've been doctored, we can tell. Now, we're not going to describe over the air how we do this.
Right, don't.
But what happens is that we can actually distinguish an untampered photo from one that has been. And we've gotten through hundreds of these things. And it eliminates a lot of arguments in the meetings, like, well, I think it's this, I think it's that. Well, this definitively puts it to rest. It's a fake. Here's the reason. This is where the fractals don't go through the object. It's not part of the background, integral parts of the background, as an untampered picture would. Now, that doesn't mean that you can't have a drone dressed up as a UFO in a picture that's been taken. We're working on other algorithms to try to denote that. But for right now, we can tell whether an image has been photoshopped in that respect. And it even works for the paranormal. So if somebody wants to hype up a picture, we can also analyze it through our fractal analysis.
Well, you could have an endless job then.
Well, we get a lot of requests from a lot of people that want to know, is this picture real? Is it fake? And we can pretty much tell you within 30 seconds whether it is or not.
30 seconds? Wow. Fast.
It's a very fast algorithm.
Okay, so how does it work when a professor like yourself, and you've been in serious teaching situations, obviously. Do you still teach, by the way, at the University of Nebraska?
Oh yeah, and 3 other colleges.
Okay, so
I teach between 7 to 9 courses every semester.
Wow, busy.
It's like 75 semester hours.
Yeah. So okay, here's what I'm wondering: how does somebody in your position, who is not afraid to talk about the sighting that you just explained to us, and moreover now runs MUFON, how does he deal with his colleagues? How does that work out? Is it, I mean, do people sort of chuckle at you, or?
Well, I'm the faculty advisor for the university club, and actually it's a MUFON, sanctioned MUFON university club. And I'm the faculty advisor for that and the Paranormal Society as well.
Wow.
So my Saturdays are spent a minimum of 4, mostly 5 to 6 hours every Saturday at these meetings. And the students run them. And then the other organizations, other public organizations, they also meet at the same time, and we all get together. And we share techniques and technologies and everything like that.
All right.
So works out really nice.
All right, that's wonderful.
But as far as fellow colleagues laughing or chuckling, actually, we don't run into any of that. Our geography department and geology department actually sponsors the room that we occupy on Saturdays, and which is actually one of my classrooms that I teach out of. And so we have everything all set up there. We have archives. We have just received some archives of documents from a former newspaper reporter of the Herb Schirmer case that was down in Ashland, Nebraska. And we have whole new files that we've gone through, pictures that have never been released to the public. We have everything now. So we do our own studies, case studies, and it ranges everything from abduction to propulsion to craft to speculation, what's out there, and so we cover a lot of ground. And
then I'm sure we will tonight. All right. So
I imagine so.
You actually, I'm going to jump way ahead and then we'll come back.
Okay.
You say you have developed, designed, or even built a warp drive. Is that true?
Yes. Uh-huh.
Good Lord. If that really was true, seems to me you wouldn't be talking to Art Bell. You'd be talking to, let's see, who would you talk to? NASA, I guess, would be really interested. Who else might be interested? Well, all kinds of great big media. I mean, that's a very serious claim, a space warp. And are you suggesting, and again, I know I'm jumping ahead, but I can't resist, that you may be ready to test it pretty soon?
Well, we have been in a testing mode for the last 3.5 years. We've been building all the hardware.
God.
We have a team of 8, 6 that are all the technical people, and we have one that's business and another one for communications. But the core of the 6 people are scattered all over the country, but we communicate electronically. And we have ones that are here in Omaha as well. And we design the system, put it together. Each person's different skill sets then puts that part of it together. Everything gets shipped in, and based on the overall design of the thing, then we test those sections.
That's
right now,
incredible.
We're building model number 14, our new fractal arrays that we just started to cut out on our new CNC machine that we have.
Fractal arrays that do what?
Well, the actual fractal arrays they emulate what happens actually within a thunderstorm itself.
Really?
I've gone back, over 14 years of research of pilots' claims of having a linear displacement, and which is they get involved into a thunderstorm and they get popped out and they're 100 to 300 miles downrange of where they were supposed to be.
Really?
And the Bruce Gernon story from 1970. December 4th, 1970, is probably the best documented case. I've met Bruce. I've flown with him several times. We've had extensive conversations. I've reviewed all of his materials that he had, the flight maps, his refueling logs, and all the other things. And, it's...
What happened? Exactly what happened to him?
He was on a business trip with his father and another business associate down to Andros Island. And to set up the story, you got to understand is that there's no refueling. There's a grass runway down there at that time.
Where is Andros Island? Caribbean?
Yes. And it's south of Bimini Island.
So it's out near the Bermuda Triangle, actually.
Well, yes. Right.
Okay.
And now there's no refueling station. So what you carry in is what you carry back out.
Mm-hmm.
And so the uniqueness of this particular story, and there are other ones that also come into play as well, but his being more documented, he takes off at Andros Island at 3 o'clock in the afternoon. He gets near Bimini, clouds begin to form and circle up and around his aircraft, which is about a 30-mile diameter, but he's looking around, and these things are going like 65,000 feet, which is not unusual out in those areas.
Big. Well, that's still big.
They're tremendous, but his aircraft was an A-36 Beach Bonanza.
All right, hold it right there. That's what we call a hook, and actually a perfectly timed hook at that. The clouds are circling the aircraft. The cloud tops are at 65,000 feet. And when we come back, we'll find out what happened.
Every time I think about it, I want to cry. With bombs in the devil, and the kids keep coming. The way to breathe easy, no time to be young.
While midnight sweeps across America, you found an oasis for the mind. To call Midnight in the Desert, please dial 1-952. Call Art. That's 1-952-225-5278.
One time a night it does that. Hi, everybody. I'm Art Bell. This is Midnight in the Desert. Professor David Harris is here. He has invented a warp drive. This is serious stuff. Really serious stuff. But at the moment, we're talking about how he got there, and that involves, at the moment, a flight down into the Caribbean. And I guess with only a fixed amount of fuel, and now storm clouds gather about the plane with tops at 65,000 feet. And I think that's about where we were.
That's correct.
Okay.
All right. Well, a typical flight that he would do is about 210 miles from West Palm Beach down to Andros. And when he left at 3 o'clock in the afternoon, with all the alterations in his flight path, ended up going about 250 miles. However, the typical flight would take 75 minutes. And his flight on that day, in 4 December 1970, took 47 minutes. So there was a 28-minute delta time difference.
Right.
And the expenditure of fuel would, with an 80-gallon tank, he had the extra modifications in the wing tanks to hold 80 gallons on that aircraft. The typical fuel used would be 38 gallons in a round trip. Like I said, there was no refueling when you get there. And so whatever you came in, you leave with.
Sure.
So when he hit up into the Bimini Island region, there were the clouds, the thunderstorms were beginning to close in around, and he saw an opening between these two last building cells going up very quickly. And there was a hole, and you could see blue sky onto the other side. Pilots referred to these as like sucker holes. And it happened to be going in about the right direction that he needed to get to land. So he went and he took it. And as he went through this, the girth of these clouds out into the ocean areas are greater than 5 miles. They're many times into the 10 to 15, 20-mile thicknesses.
Right.
And as he went through this tunnel, which would have taken him literally minutes to go through, he said within like about a 20-second interval from entering to when he exited, the aircraft just went sped down this tunnel, and the clouds began to rotate within the tunnel and then start to touch the wingtips of the aircraft, which is about a 30-foot diameter.
Wow.
From tip to tip. And as he came out of it, everything kind of went like a grayish color, gray-white color, where ionization from the cloud adhered to the aircraft, because it looks just like an antenna. It looks like an omnidirectional antenna.
Okay.
And this, what he calls it electronic fog. But in reality, this is just ionization from the intense electrical fields within the thunderstorm. And these things can reach out close to 25 to 30 miles away from clouds, ionization of the air. And so it adhered to his aircraft. He can't really see anything. His instruments have gone haywire.
That's what I was going to ask about, the instruments.
Yeah, the compass is spinning, everything's all haywire. It's a brand new airplane, and he's kind of perplexed here. He's still flying the thing. He indicated that he felt the aircraft hydroplane slightly, and he had a very slight feeling of weightlessness. And then suddenly, about 3 minutes later, and during this time period, he's calling to air traffic control, approach control, and he's saying, "Hey, look, I'm here in Bimini. I can't see. Can you see me on radar?"
Quick question. The brief feeling of weightlessness, if you're in a plane, that could come from a sudden loss of altitude?
That's correct. But as we still explore this particular story, and we relate it back to the theoretical concepts of Miguel Alcubierre in 1994, he lays out a very specific procedural thing of why people in a warp bubble, how they would feel, the momentum. There wouldn't be any momentum. In other words, you can make 90-degree turns. There would be, the bubble would have certain characteristics. And in his case, as we determined, or as I determined, was that he fits all the protocol for what Alcubierre was talking about. And interestingly, it was a non-sustainable warp bubble that allowed him to be a linear displacement of 100 miles from Bimini to Miami Beach, because the radar operator tells him on the radio, the only aircraft I have is over Miami Beach. There's nothing in Bimini. And he gets all upset. And I guess the passengers are getting kind of upset as well.
I'm sure.
Because nobody knows where they're at, and people are telling them we can't see on radar. And you got to remember these approach radar control things, they rotate 4 revolutions per minute. So he's gone in one of the 15-second rotations, and he reappears on the next scan, another 15 seconds, and he pops up in Miami. Well, I did some calculations, and what we're looking at is this 100 miles that more than likely he went there. He actually went from Bimini to Miami Beach in about a second, and more than likely less. And once the bubble then dissipated, then he was left back over that vicinity. Then the electronic fog, that disappeared as well. And then he could finally see what was going on beneath him. So that would be 360,000 miles an hour.
Right.
Now, the aircraft wings fall off on this airplane. They start getting structural cracks at about 210. You don't ever exceed 220.
No, I've got it. He didn't do it in the aircraft.
Yeah. I mean, there's no way this aircraft could do this. And so if we look at the total time, even if we try to go back and try to disprove what he was able to do 250 miles in 47 minutes, you still got to go 319 miles an hour.
Sure.
It's impossible for that aircraft to do that. All right. So he clears with the tower. He clears with the approach control. He gets to West Palm Beach. He's kind of baffled by this whole situation. He lands at 3:47 in the afternoon. So he's got verification of people seeing him take off at 3. He's got verification of people seeing him at 3:47. All right. He goes and he refuels the aircraft because this guy does everything by the book. And when he lands, he refuels the aircraft. I got his refueling ticket. I got a copy of it. And it indicates that on that day, he only used 29 gallons.
I think I would have started drinking heavily, and he goes right back to refuel the aircraft, huh?
Well, he's not that kind of guy.
I understand. Actually, I don't drink either.
Right,
just
right to the pumps.
Yeah.
So he typically would use 38 gallons. He has 9 gallons of fuel that was never expended. He only put in 29. Usually uses 38. So there's 9 gallons of unexplained overage on the fuel that he never used. And so if he would have went the 100 miles, he would have used the 9 gallons of fuel.
So in most every way except a tragic end, this is like every other Bermuda Triangle aircraft story that we've heard, right?
There are different variations. However,
there are, but
it doesn't just situate itself here in Bermuda Triangle. I have a case in England of a Tiger Moth in World War II. It's a biplane that was doing radar experiments, and a pilot got caught up into a thunderstorm. He saw an opening in the thunderstorm, drove the plane through to the blue sky. He ended up in northern England. He was flying over North London. And he came back to his base, and, he landed, a little bit of damage on the aircraft and stuff. But he was displaced. And then we get into Kwajalein to Guam, where Lieutenant Colonel Frank Hopkins, his navigator on a C-97, gets linear displaced 300 miles.
Wow.
And a 6.5-hour trip takes 5. And he writes a letter to Argus magazine back in the 1960s after he retires. And I checked the guy out. I mean, the guy was a master navigator. But there's no way that aircraft could ever get to its final destination in 5 hours versus the typical 6.5.
Okay, in every case that you've discussed, this electronic fog is involved.
In some of the cases, others that the plane just goes, and they see them. Sometimes the aircraft is flying at night. In the case of the C-97, it was at night.
Mm-hmm.
So there weren't any other reference points. So we don't know exactly what happened, but we do know that there was a displacement. So the curiosity of it all, is not just resonant to the Bermuda Triangle region. It will occur anywhere in the world when the conditions are just right, because these thunderstorms that just because of unstable air conditions, I mean, they just rise and they can get very severe. But as the electrical fields increase, they actually produce positrons, and you get antimatter being generated within these thunderstorms. It's a recent discovery. It's about 2010. There was some research that was done prior to that, but the official papers came out in 2010 telling us that there were actually antimatter, trillions of these things within thunderstorms all over the world. And it was detected by the Fermi spacecraft that they sent up to purposely look for antimatter out in the universe.
That's incredible.
And if they would have they didn't ever realize this, but the discovery was that the Earth is loaded with this stuff, and thunderstorms produce it.
But antimatter cannot just continue to exist. It's in the presence of matter, so something happens.
It annihilates. And so it generates over 500,000 electron volts within the cloud.
Okay.
So it's one of these things, the kind of the straw that, broke the camel's back here, is that this increase in energy is more than likely part of the precipitating effects that in the generation of these tunnels where the pilots go through,
right,
the fields cross from storm to storm. And the fields themselves, the way they're structured within the thunderstorm, are, and you're familiar with this, the concept of a dipole, plus minus.
Yes, of course.
Well, in the thunderstorm itself, of what my research and verified by other researchers out there, particularly like Earl Wilson in 1984, talked about the generation of these dipole fields, plus minus, minus plus, an inverted dipole at the bottom of the thunderstorm. And with that information, it became very clear that between these two thunderstorms, when all these fields crossed, there was a sweet spot. And in the freezing level of the thunderstorms, this is where you would find this. And this is where, in this case, Bruce Gernon went through. And in the case of the pilot in England during World War II, during the fall time period when he was flying in through there, the freezing levels were lower, and he didn't require oxygen. And you don't need oxygen unless you go up above 10,000 feet.
Right.
But in both of these instances, these guys are going down in through the freezing level and popping out, in Bruce's case, 100 plus miles away. And the only other explanation at this point is we have tremendous amounts of energy. We've got these tripole fields existing within the cloud structures, and these aircraft are being displaced downrange. And Alcubierre's theory parallels the exact statements that were made by Bruce in particular of what transpired during this time period, what happened after that, and those other descriptions of the aircraft instruments going offline on that.
Okay, so in each case of this, you've described several. I'm sure reports are made. The truth is told. It's considered and probably
discounted,
rejected one way or the other, I'm sure.
Yes. And, being a pilot myself, being involved in aviation since I could almost crawl, and being involved in radio and electronics and everything else, I listened to these guys.
Right.
And, the verification of Bruce, extensive conversations. So the other people could consider this to be anecdotal. However, I didn't. And
now that you've explained it, I don't either. I mean, obviously, there's an effect here, an amazing effect, and it can't just be written off.
No. And being a weather observer and a forecaster when I was in the Air Force and also a radar operator, I mean, I've measured, seen, collected data, and written models for, the numerical weather models and that. I've gotten the full gamut of within the weather itself, and also then being involved in aviation. I understood what these guys were going through. And the bottom line of incorporating concepts from Alcubierre was the handwriting on the wall that nature actually does produce this. One case, okay, maybe the guy's a fibber, right? Two cases, well, 3 cases, 4, 5, 6. There's something going on here.
Agreed.
And if nobody wants to believe these guys, I'm doing the investigation. And so I was playing detective. And it didn't dawn on me until I began to realize the concepts of the cross fields that go on between the thunderstorms when they're side by side like this. And I said, okay, well, why don't we try, and what I did was I investigated 35 cases in the Bermuda Triangle because I had availability to the data. And out of those, I randomly picked 22 cases. And then from there, I started to analyze each case and did like a weather forensics on it. And I started to note that these disappearances of these aircraft all had similar weather conditions in the sense of when the thunderstorms evolved in the early, like late morning, early afternoon. And then the plane goes out, it's clear, and they never come back.
Right.
So unfortunately, there are a lot of pilots that succumb to this stuff, maybe pilot disorientation, mechanical, maybe other types of occurrences.
Okay, I do have a question.
Yeah.
I understand the nature of the storms in that area, and they can get very violent, cloud tops very high. We also, though, in the mid part of the United States, spring and fall, we have very, very similar conditions with gigantic thunderstorms forming, frequently producing tornadoes, but really high cloud tops. So what's unique, do you think, about the Bermuda area versus the central U.S. bad storms?
Well, when we talk about oceanic thunderstorms, and this is anywhere in the world,
right?
It's that you have light variable winds aloft, and you have tremendous amounts of heated water beneath of it. So you got tremendous amounts of water vapor that then stimulate these unstable conditions. And if you're in the Bermuda Triangle, which I've flown in there several times, it's hazier than all get out. I mean, you can hardly see the hand in front of your face. Now, I'm exaggerating there. But in the case of like when we were flying down there, we were doing some TV shows. We had 2 aircraft take off within like 5 minutes of each other.
Right.
It took us a half an hour to find each other. And and they're identical aircraft with the same kinds of capabilities.
Wow.
It took us 20 minutes to locate each other in the sky. Then we shot the film and all this kind of stuff. But in addition to this, you see cloud structures. It gives phantom islands beneath. So that area is like very misgiving. And if you don't have a GPS, and if you're not an expert navigator, you're going to get lost. But in the case of these clouds, they will pop up very quickly because of these conditions. Now, versus land-based thunderstorms, they...
Okay,
yes.
no, I get the difference. I would think then that Southeast Asia would be similar.
And I don't have any data as far as aircraft losses and things like that I have studied there. But yes, from what I have seen in the Pacific, into the Atlantic Ocean.
Right.
And yes, anytime that these conditions, which basically you're talking about energy from space coming in from the solar winds.
Right.
You've got this stuff as they call it as the introduction of this plasma, the flux transfer, and it's not the flux capacitor here. We're not back to the future here, but the flux transfer is an actual component of where excess amounts of energy from space hit into the upper atmosphere and can alter the atmosphere.
Got it. Professor, I'm sorry, I've got to break in. We've got a quick break here, 2 minutes. We'll be right back. Professor David Paris.
At the speed of light in the darkness, this is Midnight in the Desert with Art Bell. Now, here's Art.
So I played this so somebody would, I'd remind myself to ask you to please wormhole me the Denver score. Didn't get to see the end. So please, welcome back, NFL. God, it's great. It's like life begins again. Well, it's not that serious, but pretty serious. My guest is Professor David Paris. And boy, are we ever involved in a fascinating discussion. And I'm just going to say this because I'm just going to say it. Who else do we know recently who went through something that was very high voltage and was on the show and got displaced? And I'll drop it right there. Professor, welcome back.
Thank you.
Okay. So, yeah, I'm completely buying this. I'm with you all the way. And so this electronic fog is created, and things that enter it frequently become displaced. In other words, you go... I wonder if you can even guess, Professor. It's not the speed of light, perhaps, but it's really quick.
Yes, and in essence of what we're trying to attain. Right now, we're just kind of crawling, and our results of all of our experiments are more than just encouraging. It's pretty much defines the fact that it really is true. What we have done is to replicate the internal functions of these fields from the thunderstorms. And originally, after these flights, in particular, talking with Bruce, what I did was I made some forecast parameters, and I started to figure out when would these types of clouds begin to form. And the idea here was to take a UAV and to fly it into a sucker hole and to see if we could recreate this experience and have all kinds of instruments on board and everything.
Right.
Well, we had some pilots that agreed that they would help fly and chase the UAV, and the fact that we would be outside the territorial limits of the U.S., we wouldn't have to get permission to fly one of these things. And we could fly it through one of these thunderstorms and then see where it ends up. Well, as the thing progressed over several months, everything looked good, but then everybody started to back out. They thought it was too dangerous. I was a little disappointed, to say the least.
I was going to say it was dangerous.
Oh, well, yeah, but I mean, sometimes in order to gain the knowledge, you got to take some chances sometimes. And it was a calculated risk, I guess. And as it turned out, we didn't do it. But I did take this one step further. I said, well, look, my thought on the matter was, if this is produced by thunderstorms in these types of fields, why can't we reproduce it in the lab?
Right.
So after a lot of these TV programs, I always brought a lot of instrumentation with me in the aircraft. Well, I was taking measurements, gamma rays and frequencies, and clouds vary in frequency from like 6 megahertz up to gigahertz into the tops of the clouds.
Sure.
And so what I did was I selected a frequency that represented the freezing level, and I built a set of basic antennas, which were 2 dipoles. One
at about what frequency? You said at the freezing level, which is represented by what frequency, roughly?
Well, I don't discuss that.
Why not?
Well, because that's part of the characteristics of our special arrays that we have.
Okay.
Um,
Okay. I'll accept that. I understand what you're doing is.
I mean, we
proprietary.
could probably use a lot of other frequencies, but we have gotten the results that we have with this particular set of frequencies, and therefore we don't really talk about that.
Gotcha. No problem.
Part of it.
Had to ask. Sorry.
Yeah, well, of course,
Yeah.
of course. I understand that. That's why we have our websites, and that's why we have our Facebook, and we post there all the results of our experiments and what we're doing and things like that.
Okay.
But we don't give everything away.
Right.
This is not. I mean, we do hold back some things that we've discovered. Okay. Anyway, so we replicated these things into the lab. We fired it up and we threw a laser between here. We actually built our own interferometer, and what that did was give us a fringe pattern on our projection screen. We took pictures of it, and we began to notice when we had it off, the bloom would open, and when we turned it on, the bloom would close. And so we did some analysis on that, and we figured out what was the spacing characteristics there, how many nanometers that actually turned out to be.
What do you mean balloon?
In an actual fringe pattern that is projected as a result of the lasers hitting to the projection screen,
Right.
it forms like a circle, and there's like kind of wave patterns into the light that's projected on the screen.
Got it.
And there's actually you can see differences when the system is on and when the system is off, and that's what we did. We took lots of measurements like that, and the end result was we detected the fact that when the system was on, it compressed the laser beam into the screen, and when the system was off, the laser was then unaffected. And then we also did another experiment where we just were outside our Faraday cage. We ran the laser through there, through the motor, right through the midpoint of the focus of the motor,
Right.
and we got the same results. So we did a number of different experiments because we're probably the bigger skeptics than anybody else in the world.
So you were bending light,
Well, we were compressing light.
compressing light. All right.
Yeah.
It would look
And
like it was bent.
Well, it just means that the center of this thing was more compressed
Right.
than open when the system wasn't on. So we got these results, which was very encouraging. And then I also did a test for redshift. If this was truly an effect, then we should be able to detect a redshift in the frequency, and we did. And so we did numbers of measurements on that. That meant that the frequencies were being pulled into the motor. The device that we have, and if everybody in the audience starts looking at the pictures, you'll notice is that this thing is shaped like a V. Most people would look at that and say, well, it's got to be thrusting. It doesn't thrust, it pulls. So everything goes in towards the V shape,
Right.
which is, is extremely unusual because the way this thing is set up, you wouldn't expect that, at least, the normal observer looking at this thing. But our results have indicated that it creates a field, we call it the warp field, but it draws it into the engine. And we've even gone as far as taking an isolated case made of glass in a wood structure, top and bottom, and we have a torsion bar inside, and we mount weights on it.
Right.
We have ferrous material and non-ferrous material. It pulls the materials, whether it makes no difference what it is, it will pull the material on the torsion bar towards the engine. So that's another indicator that the fabric of space is literally being torn, is being moved through solid objects and being affected by something that's stationary, in this case, a torsion bar, which is freely suspended. Now, some people will claim, oh, you're just electrifying the air. These experiments only run 15 seconds at a time. There's no way you can energize or charge the air in that little amount of time.
Right.
And plus, we're over 140 centimeters away from the target. And, and it's in a Faraday cage and all this type of stuff because, we're still analyzing everything and all that, and we want to protect ourselves.
Of course.
but it's moving these objects, and this all occurred at less than 100 watts. And so we have built new linears that allow us to bring the wattage up to right now we have capability of up to 2,000 watts, and before the end of this month, maybe the first week of October, we're going to go to 4,000 watts.
Is there, as you go up in wattage, is there a linear?
It's actually exponential.
It is.
And this is the most exciting part about it, and that's why I'm very happy to talk with you about this, because this is probably our one. It's not just a discovery that warping of space happens naturally, but it's also is that we can artificially induce it. Now, some will say, well, if you're doing this, how come other people aren't doing it?
Yes, of course.
All right. So now we kind of make a slight shift over here to NASA and to the Shire EM drive. And many of the people in the audience probably have heard of that development of that engine. They take microwaves inside of a chamber in a cavity, they bounce them around, and it creates a thrust. So they put in several hundred watts of power, 1,000 watts of power, and they can actually get a thrust out of here.
Right.
Which is, very small amount of newtons here, of energy coming out. Well, in comparison to current ion drives and things like this, these particular motors are being looked at as replacements for these things because it doesn't require fuel. Well, it's the same thing for our motor. Now, they detected inside of their cavity, and they've published a paper, is that they've detected a warp bubble inside of the cavity, yet it still produces a thrust. Now, ours was specifically designed to alter the fabric of space, and we draw the fabric of space or compress it into the motor. And this is the actual way this thing works. And our results are quite impressive. In other words, we put in 900 watts of power. Mm-hmm. We can see it being displaced down on our projection screen, 20 centimeters of linear displacement. Wow. And that's a 0.36 newtons of force. Now, we have, I was hesitant on doing this, but I put the charts out, the predictive line charts, out onto the Facebook. And these things are really shows what happens exponentially. And the encouraging piece of this is that with our 4,000 watts of power that we have, by the end of the year, after I've done the full testing of this, you got to realize I'm working 5 jobs.
I'm becoming aware of that. Yes.
I only have a few hours every day that I can devote to this stuff.
Mm-hmm.
And I do. A lot of times I'm out in the lab until midnight or 1 in the morning running these tests, and everything takes inordinate amount of time because of setup, process, procedure, because, again, we don't report to anybody, but for ourselves, we keep our records, and so we have to make sure that everything is consistent, temperature, pressure, humidity. We want to know what affects variations.
Right. What are your projections for 4,000 watts?
When we go to 4,000 watts, our 440 pounds at 2,000 newtons of force.
Wow.
And this means our spacecraft that we have, which is a 1/4 scale of a full 30 by 30 Bluebird 2, we have a 1/4 scale version of that, 7 foot by 7 foot. And it is in its construction phase. And you can see pictures of it. It's pretty much completed. It only weighs 40 pounds. So what we're hoping to do here is to get this thing off the ground, because this is what everybody wants to see. Everybody can look at all the data they want. They can talk and talk and talk and talk until they see something fly off the ground. They don't care.
Right. I know.
And one of your first comments in the beginning of the show, well, wouldn't NASA be interested in all this?
Yes.
Nobody's really interested. They're all sitting on the side. Okay, this is how I interpret it. Of comments that are made and all these types of things, it's really kind of silent. And I don't care. It doesn't make any difference to me because we're independent.
At the very least, DARPA ought to be knocking on the door.
this really needs to be in the public venue. It needs to be commercialized. We need to go to space. We need to have a space-based economy.
And that reminds me to ask you, have you considered performance in the atmosphere and out?
Yes.
And?
This will work in the atmosphere. It could change the whole transportation systems that we have. In other words, being able to cross the Atlantic and, you can set the margins to how fast you want to go across, but you literally cross the Atlantic in less than a minute. You know how much fuel you'll be able to save? And I know a lot of people are going to say, uh-oh, here it goes. This guy's going to be a target now. Well, I can't help progress. I mean, well, am I supposed to wait on this for 100 years?
Nope.
Till everybody makes their money?
No.
I think that we need to do something now. We need to have a device that allows us to go to space, and instead of spending $30,000 per pound to get materials to space,
I'm so with you.
Yeah, we need to get it down to $1.50, less than $10 a pound, to get it to space and back. And this opens up a whole new cadre of production, manufacturing in space. It allows people to go to space and come back and sleep in their own bed if they wanted to, or go to the moon and mine, go to Mars, go to the asteroid belt. And instead of taking 10 years to get to Pluto, you make it there in about 15 minutes. If you have adequate amount of energy and you're compressing the fabric of space in the same manner to which we're doing it at a lower power component here. But as I'm seeing, and as a direct observer of my experience at 16, that's exactly what this thing was doing. And I'm making a supposition here. I can't actually state emphatically that spaceship that I saw, the flying saucer, was powered by a warp field. But it sure looks like it. From my investigations here, now I may be totally off base, but the results that I see here with this exponential component here on the predictive line and the amount of power needed, there's a break point here. And once that thing starts to go up, it doesn't take much more power to literally go in a new equivalent velocity versus the
Professor,
amount
a quick question. Is
tonnage.
there a way to slow down the speed? In other words, everything we've talked about is like a very fast, instantaneous transfer. Would there be a way to essentially damn near hover using the same technology? And before you answer that, this is where we have to break, so consider that answer. The craft you saw was, I think you said, doing 20, 25 miles an hour. All the previous instances of this kind of thing, it's been very fast and very instantaneous. So how would you modulate that, I wonder? We'll be right back.
Everybody's looking for something. Some of them want to use you.
To initiate a dialogue sequence with Art Bell, please coordinate your phalanges and call 1-952-225-5278. That's 1-952-CALL-ART.
I know for some of you this is very technical and you're probably rolling your eyes and going, I don't get it. So get this. What we're talking about here is real. Now, presently we use giant rockets to get into space. We go to the moon. It costs a fortune, so much that we don't want to do it anymore, apparently. We dream of going to Mars and beyond, but that will not happen with present technology, certainly not economically. If we made a statement that we wanted to go to Mars, we'd be cutting a lot of budgets to do it. So what the professor is talking about, the implications of what he's talking about, are so incredible that it's a real stopper, a world stopper. And if DARPA or somebody or NASA isn't knocking on his door, they damn well ought to be. I guess I'll go back to the question I had, and that is the craft you saw, of course, was going very slowly. So would there be some way, Professor, conceivably, to modulate this so that you could either be stationary or you could be going from here to Japan in about a second?
We've developed a throttle for the system. Earlier this summer, we came out with our first throttle control. And since then, we've developed a more integrated throttle control with software. And so I have the thing, I've written a software that interfaces to the throttle, and we can turn the system on and off to make sure that if any readings that we're seeing is abnormal, that we can shut the system down. We collect data with the software.
Can I ask how it works? How you throttle it, or is that proprietary?
Well, it is proprietary. We do have a patent pending, but we are not going to seek a patent on this.
You're not?
No, because the problem is in the early 50s, the Congress passed a law saying that they had the exclusive right to go into the patent office and take whatever they wanted and deem it national security or whatever.
Yeah, they can also walk into your office and take whatever they want, so be careful.
Well, they're going to have a big fight on their hands legally because these are company proprietary and trade secrets.
Huh.
And since it is
I'm
a
sorry,
private
I don't mean
company,
to laugh, but they don't care.
Well, yeah, I understand that, but I've tried to figure out. Well, that's why we also are in the public venue of putting out a lot of our materials, not everything, but letting people know. We've had over 75,000 people hit our site. So if we go away for some reason, there are going to be a lot of people saying, hey, what happened to these guys?
Mm-hmm.
And, we're spread out all over the country. So, they want to come here.
There's a family right now near Area 51 that's about to get kicked out of their property because the government's going to declare an eminent domain, take their property, and that's end of that. They're on a hill overlooking Area 51.
Well, I think we've got a real problem with personal rights and intellectual property here that when the government feels that they can just come in and stop you from doing anything. What kind of freedom do we have here at that point?
Oh, well.
Then we're just, then what's the advantage of doing progress? What's the advantage of coming up with new ideas outside the box? I don't report to anybody. And if I was in a NASA component or other organizations, I'd have to go through design routines, engineering reviews. I would have managers on top of me saying, no, this is impossible. Hey, I don't care what anybody else thinks. I'm out there as an independent. And I've put my money where my mouth is. And I fund this thing. And we do have a donate button that came up because people keep sending us emails. We want to give you money. All right, fine. So, and what they're talking about is like $10, $20. They just want to be a part of the development of what we're doing.
I get it.
And believe me, it really doesn't amount to anything, to much of anything. We're talking a few $100s here. But I did that, and actually cost me more money than what we're ever seeing from.
All right, let me ask you this. When will you get to the point where you can do, or could do if you wished, a public demonstration that would leave no doubt in anybody's mind and would bring the door knockers that have thus far not come? You know what I mean, that kind of
yes,
demonstration.
Well, I'm very hopeful with this new 4,000-watt system that is being developed right now, and to be able to actually deploy this, because this new system is going to be battery-powered. We'll no longer be plugging into the circuits into the house here to run this thing.
Gotcha. When you say deploy, you mean what?
I mean being deployed in the Bluebird 2.
In an aircraft?
In a 7-by-7 foot craft. The pictures are onto the website and also onto the Facebook.
Wouldn't it be better to do this at ground level first?
Well, it will have a first, before we put radio control throttles inside that we operate from outside of the craft.
Right.
We're going to have a cable that goes up and in that we can control it. So this demonstration will be from the ground up a few feet.
Okay.
How much more do we have to do?
Oh no, that's fine.
And that's what our goal is. And it will probably. I hate making these estimates because when Murphy's around, that's Murphy's law.
Yeah, I know.
Always comes knocking at my door. my door.
Everybody's.
And it just seems like when you're in this kind of involvement of, we don't buy our hardware from some electronics firm. You know what I mean?
Right.
All this stuff is custom. We may buy some basic boards, and we do use some very advanced power amplifiers, the MOSFETs, the LD MOSFETs.
Right.
We use a lot of that new technology, and if that stuff hadn't come out, we wouldn't be able to do what we do because, these linear amps that we build, they're only like 3.5 pounds. And so when we're going to strap 4 of these guys together, hook them up to our engine, hoist it up in a vertical fashion, and, go inches or feet off the ground, like I said, and like you're suggesting is that, well, how much more do you need to do? So it operates in an air environment, and it would operate into a spaceborne environment. So, all the conversations and, I've seen pretty much everybody's comments one way or the other. It doesn't affect me because, again, if I was to be influenced by anybody out there making their comments, then I would never get anything done. Oh, I just ought to close up shop because it's not possible. And I don't work that way. UNO is considered to be their icon is the Maverick. I am the Maverick, in a sense.
I understand. Believe me, I understand. If I ran this program based and took actions based on the comments of people who listened to it early on, middle, and end of the show, God knows what I would do. So you can't listen to people. You have to keep going forward with what you know is right until you figure out maybe I'm wrong or you are right. I mean, you just can't listen to other people. That's all there is to it. Professor, hold on. We'll be right back.
Midnight in the Desert spans the world. To call us from outside the U.S. and Canada only, use Skype with a headset mic if on a computer and call MITD 55. That's MITD 55.
Good evening, morning, afternoon, whatever the case may be. This is really serious stuff. My guest is Professor Paris. He's president of the Space Warp Dynamics LLC, his company formed for this reason, a newly formed company that's conducting research and development of the first functional space warp motor. Serious stuff, folks. He teaches as an adjunct professor at the University of Nebraska in Omaha, teaches astronomy, meteorology, geography, geology, has taught college physics for 6 years, over 6 years now. So understand who you're listening to. Professor, so you are in time, how far from the kind of demonstration that you talked about a little while ago?
Well, once the 4,000 watt system is fully assembled and delivered here, and then we test it and integrate it, we might be able to actually begin to see some really incredible results here by the end of the year. That's what I'm looking at.
The end of the year.
There's a lot of work has to still be done. We're in the process of building Model 14. There's actually been 13 engines prior to this one that we're building right now. Each one has improvements, modifications, things that we've learned and discovered and get incorporated into the new design. And these things aren't a trivial thing. You just sit down and knock one out in an hour.
Right.
I mean, these things take months to do. And with our new CNC machine that we bought, we have just got all that software up and running, and we've gone through our testing to actually begin to mill these things out. And we have 7 of our new fractal designs that have been milled out, and we need 16 for each one of the for an individual motor. And we can scale these up. We can scale them down. We utilize fractal technology in the sense that it allows us to compress and provide and put into a lot of forward power into the arrays,
right,
and to generate these effects that we've described over the last hour or so.
How much gain do you get using fractal technology?
Well, here was a situation that I was trying to envision. How do I artificially induce this? Do I set up 2 huge radio towers, fly an airplane between, and generate 10 to the 7th watts of power? I mean, in the free environment of thunderstorms, you get up to 10 to the 15th watts of power generated between these storms. And, that's the kind of environment that these things generate. So I was pulling my hair out trying to figure, well, what's the next big thing? Put up these antennas. And then I started to think, no, you're going to have to come up with a concept, a device that is a motor. And it could be attached to the aircraft or could be designed into a spacecraft. And so we came up with this pod design so we could actually repurpose vehicles, ships, or whatever that wanted to use one of these devices. So it's across the board. You could use this on varying sizes to lift a refrigerator.
Sure.
Put it on a wheelchair.
Okay, Gary sent me a computer message here. I get them all the time through what we call the wormhole, interestingly enough. It says it takes so much energy to lift a spacecraft. Where does that amount of energy come from and not violate the rule that less energy in is more work energy out?
Well, this doesn't violate the rule in the sense that the warping of space, in essence, what we're doing is not unlike what the planet Earth does, what the sun does. It alters the fabric of space in our solar system and throughout the universe. So it's just not this constant plane where everything exists. You actually have a compression field along the equator of the Earth,
right,
and also the sun. And if you look at from an astronomical point of view, you see all the planets aligned like a pizza pie, the central hub of the sun. But that's all due. It's a very, very, slight force, but it was enough to align everything along the plane of the ecliptic. Now, Pluto, being the oddball out there at 17.5 degrees off the plane of the ecliptic, could be a pick. Well, that's what the big debate has always been. Is it a pickup piece of comet, bunch of ice out there, and it just got into orbit? That's a possibility. But if you look throughout the universe, all the structures of solar systems are pretty much like our cookie cutter in that respect. But getting back into the actual question there, the verification of the essence of the fabric of space has been validated by the Gravity Probe B experiment. NASA conducts, and government monies went into these things, and it shows that the frame drag around the Earth does actually exist.
Sure. And
that the fabric of space is altered as due to mass. And so in our context of what we're looking at is that we're in relative form in around the craft itself. We're just compressing the fabric of space in front of the craft, which then decompresses up and around and then pushes this thing forward.
Okay,
now,
you still have something of an energy problem, right? Because you're going to be, when we begin talking about something the size of, say, a flying saucer, you're going to have to generate a lot of continuous energy. Now,
based on weight and based on how much do you want to compress the fabric of space?
Right.
Because this is an aggregate. In other words, for example, like we go 15 seconds, we go 30 seconds. The distance of linear displacement on the motors
That's true.
are actually an aggregate of that. So the longer they stay on, the further the distance they go, and in more power that you provide, then the fabric of space is compressed even more. Kind of think of this as kind of like an accordion. Stretched out as normal space, compressed the accordion. It's the same amount of space that you have when it's stretched out. And now it's the same distance, except it's just closer to the, in this case, front of the spacecraft. And so you're transiting between point A and B. And the other piece of this is that our anecdotal evidence of the aircraft that pilots reported over the years, they accomplished the same thing. And the other interesting piece of this, and I need to mention this, is that this fabric of space is not just a straight line. It actually conforms to the mass of whatever's around. In other words, in his case, he went in at 10,000 over 100 miles. If he was a straight line, he'd be out in the upper atmosphere.
So if I'm understanding this correctly, if you had a craft that you had built and you went from here to Mars
Yes.
in a matter of seconds, you would not be actually traveling faster than the speed of light. The effect would be traveling faster than the speed of light, but you really would not be
That is
doing
correct.
that, right?
Yes, absolutely. And we refer to this, at least in our jargon here on our team, we refer to this as equivalent velocity.
Yes.
And so it does not violate anything in general relativity, because what we're doing is we're just kind of scrunching up the carpet and stepping over from point A to B.
All right. Now, that doesn't mean there are not dangers that you cannot anticipate in doing this.
Well, that's another thing that, again, research will prove out what happens when a particle enters into a compression wave in front of the craft. Does it go right through there, right through the motor, right through the craft? I can't answer that. I suspect because of the compression, and this is just, again, I will never tell you something unless I know it actually works. And this would be totally speculative, but it appears to me from my observations that perhaps would actually route around on the compression field and then exit onto the sides of the craft. However, I don't have verification for that, but that's what I'm speculating about. Now, we also, you'll notice if you've done some research, and that's the audience inclusive, everybody, if you've looked at what space warp is about, many of the proponents of space warp was exotic energy, antimatter, all these other kind of stuff, and generating this big bubble 1,000 meters across, and then putting a craft inside of this thing, which is, very impractical because you can't steer it. And what we've done in our pod designs is we actually can generate a multiple warp fields and combine them together. And this is how we actually have full axial control on our craft that we'll build, and initially just lift it up vertically. But in the lab, we have put motors side by side, energized one with more power than the other, and it always will turn to the strong side. So we have the ability to control the craft, and this is in our constant endeavor to generate the flight control system software. This is the whole evolution of what we do, is that we know the motors will work, and it's a question now of providing more energy, Scotty, please.
What about the effect on biologics?
We have taken measurements or radiation measurements off the motor, and it's negligible. It's like 0.7 of 1,000th of a rem of radiation. Wow. So we've done the measurements. It's nothing. The background radiation is like 8 to 12, and then during the strong side of the sun during the day, you can get up to 25 microrems. So there's 1,000 microrems in one rem. And so we're 0.7 of 1,000th
wow.
of a microrem. So it's negligible. And here's the other thing, where a lot of people say, well, you're heating the air. Well, we have infrared temperature sensors, and we look at the ambient temperature between the arrays.
Tell them so does lightning.
Well, lightning can heat up until 50,000 degrees Kelvin, easily, or 50,000 degrees Fahrenheit. In our arrays, when we shine the infrared sensor down there into the ambient air, there's no difference in the temperature. So we're not generating temperature, and we're not, in that sense of what a lot of people are accusing us of charging the air. I've discussed this with a couple of other scientists that work with the space metric of the fabric of space, in this case, space warp. And so they're on a theoretical basis. They're working on teams that are trying to evolve motors and stuff. And all the characteristics that we have identified and have actually presented on our websites are the characteristics of what you would expect to see if you definitely had a working component, in this case, an actual warp drive.
All right, now this is way out of left field, but it does occur to me that if you actually demonstrate this, if you make this work,
Yes.
you are stepping on 5 million toes. You're stepping on traditional rocketry.
Yeah.
You're stepping on airline toes. I mean, for example.
Well, they would be the biggest benefactors of something like this. I mean, a 747 uses 600,000 pounds of fuel.
No argument from me. I'm just talking about the toes.
But I mean, well, it's a paradigm shift. When are we going to accept something of a new paradigm shift? Are we that afraid? The civilization, if they want to play with this stuff, is going to have to wake up and think differently.
Well, if we don't, we're never going to get to the stars with what we're doing now. That's
and
for
I'm
sure.
a proponent to get to the stars. Characteristics of papers that I've read citing that faster than light travel in this kind of mechanism could be maybe 100 times, maybe 1,000 times. It is unknown. I don't know. And I can't even speculate in that respect.
All right, speculate on this. What do you consider the chances that when you build this model, you're going to prove exactly what you're talking about? It's going to lift and hold.
It'll be 100%.
Oh, man. You're really into something here.
The results of our experiments right now indicate we just hang this stuff from a vertical spring scale, and it pulls it down. And we measure how many newtons of force, and it's minuscule at this juncture, but it's all due to the amount of power that goes into the system. That's why we're building Model 14. This thing can take a ton of current going through it. That's the whole impetus behind the design. We are at the point where we can't burn these on boards anymore. We got to get more and more copper on there to take the current that comes across. We have to do matching circuits and all this type of stuff. There are intrinsically, like I said before, all this equipment is handmade. And this is why I don't push this stuff right off the bat. Hey, here's 2,000 watts. Just turn the throttle up and see what happens. I can't afford to do that kind of stuff. These things cost like $1,500 to $1,800 a unit.
Right.
When it's all completed, and I've got all 4 units purchased. In other words, all the equipment for it. And so we're in the final state of putting together one more amp and integrating that into a quad combiner, and so we can generate this 4,000 watts of output. And this is where we feel that, based on our predictive line chart here and the results that we've been able to verify over and I don't just do the experiments one time. We do these over and over and over again.
Science is. I think at the point that you can prove this, Professor, you're not going to have a hard time getting funding at all. You're going to be turning people away. And
well, we already actually have turned people away. That have approached us.
Because they want more than just a piece, no doubt.
Yeah, they want the whole damn thing.
Yeah, I'm sure.
And you get nothing. And it's not a point of taking all the money and then, hey, look at this, that's not the purpose of it. It's like, I put 14 years of work into this thing and 3.5 years of working in an unheated garage with minimal amount of power, and all the money has gone into this equipment, and that's just the way it's been. And so, I'm going to take care of my family, period.
All right. Well, how do you come out of this, moving away from the technical aspect for a moment, how do you come out of this more than whole? How do you end up with a piece of it? You say you're not going to file a patent. All right.
Right. Yeah,
so,
by holding it as a patent, as holding it as a proprietary system, and also trade secrets of the equations and all the other things that we've evolved and developed, we will maintain the control of the device. And our intent is to not just produce engines, but our intent is also to build craft. I intend to build, when we sell a few of these motors that we can adapt to other applications, the monies that we receive from those things, if everything works out, is that we will complete the 30 by 30 foot Bluebird, the actual human carrying craft, and we will also install in that our artificial gravity system, which is the smaller motors, because we know that they work, and we're going to create a small warp bubble within the craft and exterior to it with the motors. And so we're going to eliminate a lot of the biologic problems of humans in space. That's what our goal is. And so, yes, we're going to be extremely busy. The team will grow, but right now, nobody gets paid for anything, and they've been together with me for like well over 3.5 years now. So if that doesn't tell you that these people believe, then everybody would have abandoned the project long ago.
I'm sure they do, and from what I've heard, I do too at this point. It is really exciting.
Oh, I kind of play it down. Last week we were working on Model 13, and that's history. That's old news, and Model 14 now is the new exciting part of this whole
Professor,
thing.
hold on. I'm going to open the phone lines. So, call.
Falling in love was the last thing I had on my mind.
Remember, when calling Midnight in the Desert, let the phone ring until answered. These calls are unscreened for your listening pleasure. Call 1-952-CALL-ART. That's 1-952-225-5278.
Professor David Paris is my guest. He is building a warp drive, and he really is building a warp drive. Incredible stuff. So if you have questions, the public number, 952-225-5278, and you know about Skype. MITD51 North America, MITD55 worldwide. Professor, welcome back. Are you willing to take a few calls and questions?
Sure.
Okay, good.
We'll see where it goes.
You never know. That's for sure. Hi, you're on the air with Professor Paris.
Hi, Professor. I have a little bit of knowledge in this subject matter. I was wondering if I could ask you a couple of questions, because I've heard, people discuss on various shows, propulsion systems, and they always lose me once they get into this anti-gravity language and zero-point energy, and even when you're talking about, warping space, because I think there happens to be a simple process for ordering the direction of magnetic forces to get a propulsion effect. And I don't think you need that kind of language to really explain it. But I was wondering, when you were describing your experimental device, you mentioned there being in the experimental model, there being a couple of dipoles. And you said there was a 140 centimeter distance to the target, and then had to do with a certain frequency that you didn't want to disclose. Are you generating... when you say the target, are you generating fields between the two dipoles?
Well, it's not just, we refer to them as tripoles, and we have two panels, two arrays that are focused, and we have a certain angle between those two arrays, and this is where the near field of the cross action of these fields create this compression. And the measurements that we have taken show us that the movement goes in towards the motor. So we have redshift, we have compression of a laser beam, we have movement of ferrous and non-ferrous materials, that if this was electromagnetic in nature, it wouldn't be moving non-ferrous material. Mm-hmm. You see where I'm going from? Coming to this?
Because I was thinking that, anytime you create a source of flux, you have an electromagnetic field. And
yes.
If that field intersects with, let's say you have a source of flux, for instance, and you in the near field you have a conductor carrying electrical current. The field from the source is going to impose a force on that conductor, right? But at the same time, once you generate it in that conductor itself is generating a field which is moving back towards the source and could create an opposing force on the source, so you'll get canceling opposing forces, just like two magnets will push apart or pull together. However, there is a process, and when you're talking about the frequency, for instance, where you can create a situation where you either can create just a single force on one element, let's say, without there being a reactive force on the source element, or you can create a let's say a attractive force on one element and a repelling force on the other element unidirectionally in the same direction. So you're not going to get opposing or canceling forces. But so I wasn't quite clear if, it's hard to figure out if that's what you were actually doing or if it was something a little bit different. Because I don't imagine you're imparting any kind of electrical current on the craft shell or anything like that. This is just internal. I was thinking you were generating internal forces between your elements or your sources of energy. And to that degree, I was thinking, when you're talking about the amount of energy needed, if that is what happens and you're dealing with a specific frequency, and I was thinking that at 140 centimeters, you're talking something about 53, 54 megahertz. I don't know. But if you're to bring your elements closer together, because, things operate on a square law, you bring them twice as close, you're going to get 4 times more force for the same amount of energy.
Well, we've actually conducted experiments that go from 30 centimeters out to 140, and we look at the swing rates on the torsion bar. But you're using the same frequency all the time when you're changing the distance between your elements. That's correct.
Maintaining the frequency.
The effects are actually extend beyond the 140 centimeters that we have measured. But we had to call it quits at some point because we only have limited space. And
of course, I was going to say, of course, you're going to get a variation. You're going to go from maximum force to zero force if you're changing the distance while maintaining the frequency. But if you close the distance, you up the frequency to keep the same proportions, and you're going to get the effect is going to continue, except it's going to get more powerful. So the smaller you make your machine, the more powerful it becomes, until you reduce it to the size of an atom, and then you can imagine the forces you're going to get, and you're going to start to discover the basis for gravity, probably. But,
the engine itself is constant energy in, and the variation of distance was an attempt to show the collapsing of the fabric of space around an object. And in this particular case, we were looking at non-ferrous material and how it interacts and how it actually is attracted to the engine. Okay, it goes towards the motor in this respect. And it's in an isolated case of glass and wood, and the fabric of space literally penetrates through all of this and literally pulls it. Now, the other piece of this is we're developing a measuring device that has a set of passive Hall effect sensors, and these are our magnetic sensors. And as the fabric of space collapses into the motor, it's going to pass through it all the magnetic fields that made the resonant of the normal space. And as that passes by, we're going to be able to read and measure how this grid or how the effective field looks like. So we're in the process of doing that. We should be finished with that particular experiment. I have another physicist on the team that's working on this. He's a particle physicist, and he knows how to, we designed the circuits, and what he's doing is he's building the stuff. He's printing them out and putting them onto this grid board. And we'll put it in front on an optics table, and we'll have it at various distances to actually try to three-dimensional simulation or three-dimensionality of looking at the actual field that's created and how it distinguishes from 100 centimeters to 50 to 25 all the way up to the front end of the motor. And so we need to see how that field looks, because we know that we can combine engines together and create a warp bubble. I know that I can put another array panel up on top and extend out from the dual arrays that we have. And I can literally control the fields, altering them. And this is another added advantage into manipulating the fields of the warp fields. So we've investigated quite a few different characteristics of this, and right now we're at that point where we need to put it all together and lift this craft off the ground and eliminate people's rolling their eyes and
Professor, I'm curious. If you were to, obviously you're not actually speeding through the atmosphere because you're warping space. You're getting from point A to point B in a very different way.
Yes.
Still, there remains a question of whether there would be any atmospheric effect at all. What do you think?
Based on the testimonies of these pilots that I interviewed and had reviewed documents about, there was no noticeable tidal effects. Now, Alcubierre had talked about if you do have a warp bubble, that there would be intense tidal actions on the outside of the warp bubble.
Right.
And when Gurning came out of his thing, and he was over Miami Beach, there was no discrepancies. No one observed anything in the atmosphere of any odd occurrences going on, nor the sea level, ocean surface being any kind of abnormal characteristics there either. I have not noticed any abnormal effects of bending the light around there. But again, we're only working with a few thousand watts of power at this juncture. And I don't think you're going to really see any kind of dramatic effect until you get up into, say, 100,000 watts of power. My projection is that the way this exponential curve is going, and I've run it out beyond what I posted onto the Facebook, and man, it keeps running up, and it doesn't really go past like 5,000 watts of power, between 5,000 and 6,000 watts at the max, and it just keeps going up in a straight line. Now, however, with that said, we can get too giddy about this, and that as I continue with the methodical experiments and increase the wattage 100 watts at a time and take those measurements as we approach 2,000 and as we approach 4,000 watts, we will get a better predictive line graph of where we have a better R-squared value.
I think a lot of people listening are getting lost in some of the technical details, don't understand how this would change,
sorry.
And don't, oh no, it's all right. I don't mind at all. I'm trying to get people to understand how this would change the world.
Well,
have you thought about that?
Yes, and a lot of it, it carries a heavy weight on my shoulder because of what could happen with this particular system. In other words, being, for peaceful uses, this thing could revolutionize the way we do business. In other words, transport stuff, go to space, exploration, create an unlimited amount of jobs, people who want to live on another planet, go to the moon and start a colony, go to Mars, terraform and set up colonies there.
All of that. If you turned your mind from fast transportation, which is what I know you're thinking about, to weaponize something like this.
And this is the part that weighs heavily on my mind, whether I should go through with the whole thing or just, put it in the garbage can.
Yes.
I don't know if we're as population, and it's not just the United States, I'm talking the world, that we're mature enough to know how to use a technology like this. And because if it was weaponized, I think it would make a paranoia around the world that would be unfathomable. With nuclear weapons being a threat right now and rogue nations getting nuclear weapons, if you could deliver something in like seconds, there's no way you can detect this thing. That's the problem.
Nor even have a slight clue that it's on the way. It would just be there.
And there's no way to push a button to repel it. You know what I mean? How do you defend yourself against something that would show up on your doorstep in a second?
You don't.
You don't.
And
That's right.
I can see I can see that side of it. Ken, you're on the air. Hello.
Hey, Art, great show. And Dr. Paris, I'd also like to comment on some of those the last caller's effects.
Yeah, go ahead.
I'm a retired aerospace engineer, and I was one of those guys that checked designs and approved them for corporate and military aircraft. But I also worked with twin 50-watt CO2 lasers in stereolithography. And so I have a little bit of understanding about what you're talking about. But to put it in simple forms, have you considered the fact that this might be created from a feedback loop, not from the instrument that you're supplying power, but actually the warp that you're creating, that the warp is trying to fill in the gap of this bubble, and it's actually being enhanced by this, like a Venturi effect, where space-time fabric is trying to fill in this bubble, and this is what's causing you to see more power out than what you're putting in. And I can take my comment off the air. Thank you.
Okay.
More power out than power in. What we actually observed and measured was when the system begins to throttle up and create the warp field, is we notice a negative flux into the motor, and then it goes up to a normal load, I guess. Anywhere it's the only term I can use.
It's not really more power out than in anyway, right?
Well, this is what I'm getting at, is when you turn the thing off, there's about a second and a half where this thing puts out more power.
Oh.
It's the rebounding of the fabric of space. That's what I can only interpret it as at this juncture. Could it be electron bunching onto one of the arrays, and then there's a release at the end? That's a possibility. I've looked into this, kind of like similar to radio transmitter magnetrons.
Mm-hmm.
There's a similar like effect there on electron bunching, and so we haven't investigated that 100% yet, because our goal is we're not going to get. I don't want to be bypassed by some other team that's out there, because there's a lot of other teams out there trying to develop something similar to this. And so we can't afford to stop and, smell the roses here. We got to push forward, with caution of bio logic of, is this thing going to be dangerous? And we've taken those measurements. It doesn't appear that it is. And everything that we know right now, it appears to be safe. And our next step is to get this thing off the ground. And any other effects there, we could study at a later date, but we need to get it off the ground.
All right. Hold it right.
That's what our push is.
Hold it right there. Professor David Paris is my guest. And if you're following this, you're very, very excited. Even if you're not, and you're kind of following it, you understand the implications, I'm sure, of what you're being told. We'll be right back.
Midnight in the Desert doesn't screen calls. We trust you. But remember, the NSA, well, To call the show, please dial 1-952-225-5278. That's 1-952-CALL-ART.
Professor David Paris is my guest. He's developing a warp drive, or maybe we should say he has developed a warp drive, and he's trying to get a working model that would demonstrate beyond anybody's reasonable question that he has done exactly what he says he can do or has done. In other words, get to the next level, and the next level is that level where people are going to go, oh my God. And it's also the level where they're going to begin to knock on his door. And I'm sure you have anticipated, if it hasn't happened already, at that point it will happen. And then how will you deal with the DARPAs and the NASAs, have you already had a call?
Well, I've not had calls from them. I have had calls from other people through the backwaters, I guess, and I've just turned them down. And At this point, I can't take direction from somebody else to take a project over. I'm not done with this, and I won't be done with it. And the anticipation of when this thing is totally completed and we demonstrate beyond any shadow of a doubt what we've done, at that juncture, we would look at licensing agreements, I guess.
Mm-hmm. Yeah, I mean, that moment is coming.
Yeah, and we've thought about all of this, and my major concern is a misuse of this type of technology.
Right.
I know I will not be able to prevent it, but if everybody was in agreement, this could advance civilization to such a degree that we would reduce the famine. The economy would be a boom going into space. And this is something that we have to do as a civilization, or else we're going to die. It's not just taking care of the earth as good stewards of the land and water and whatnot, but it's a whole new paradigm shift. There are so many people out there that want to go to space. They're anxious to get there, and they want to see what they can do and make their mark into space. But it's a place that's never ending. And once you leave the solar system, maybe it's Alpha Centauri, Proxima Centauri, maybe it's Gamma Epsilon, maybe the new one that is 1,400 light years away. I believe this a mechanism with sufficient power. Now, of course, ours is operating on battery at this next plateau that we reach, but there are definitely energy generation systems there. Possibly even maybe a small fusion reactor.
Well, that's where I was going.
Or a fission or plutonium reactor.
Right. Well, after the knock on the door, after you've made the deal, then you suddenly have access to fusion reactors and so forth, right?
Well, there's a prototype in the garage, but...
Oh, really? Okay.
I mean, it's again, I'm not going to accept current understanding of how things work. I mean, I think outside the box. That's just how I am.
Clearly.
And I will stand up and be counted. And it makes no difference. Failure, success, whatever, you learn something from all of it. And it's just this, everything I've done in my entire life seems to wrap up into this project. From early days of radio, electronics, flight, and everything else that I've ever dabbled in, got into.
By the way, I understand you're a ham operator. Is that right?
Yes, that's absolutely true.
I'm W60BB.
KC0IZT.
All right, buddy. All right, William, you're
20 meters here. I mean,
you're on 20?
I am so involved in this stuff that I'm in my office right now. I have a whole rack of ham equipment here. I've seen your office on a picture. You have the same thing.
You know what I've got then.
We have a lot in common here.
So do you hang out on 20?
Uh-huh. Yep.
Give me your call again, please.
KC0IZT. India Zulu Tango.
Right. Anywhere special you hang on 20?
I usually kind of listen to the maritime band. Now, I check in every now and then. I build my own antennas and everything, and so I occasionally get on there. But this work has been so intense that I barely turn this thing on anymore.
Right, I understand. As a physicist, I would love to ask you about my antenna system. There are few things you might find interesting about it. For the low bands, I built 5 acres of antenna. It's a gigantic double loop that circles 5 acres or surrounds 5 acres. Right. Wow. And there is a voltage on it that is inexplicable. That voltage is not coupling from any power lines or is not storm related. It's there during clear air. I've got 13 towers up, actually. About 75 feet on average, with the center feed at 100 feet. And it's truly all double number 10 wires going around. And it collects a tremendous amount of energy. I actually killed a few transceivers before I figured out what was going on. I now shun it to ground. But I have watched this 13-tower array goes around both properties I have, and during thunderstorms, it is most particularly interesting. I have never been hit by lightning. In 20 years, I've not been hit by lightning. knock on wood if I could find, yeah, here's some. Every time I say that, I have to knock on wood. But what I do see is very interesting. During a lightning storm, I will see a kind of a purplish plasma form at the top of the towers. They're all grounded. And then I'll see the lightning strike, sometimes inside the loop.
Yes.
Never hitting the towers, and then that plasma immediately dissipates, just like that.
Now let me guess. Your soil's out there, very sandy, right?
Extremely, yes.
Yes. You don't have any ground. How far do you have your ground rod in?
6, 7 feet.
You don't have a ground.
Right, essentially not a ground. That's right.
Well, you literally have to go. I run into this problem. Omaha has a 40 ohm resistance at the surface. You go down 8 feet, it's 34 ohms. It doesn't really change a whole lot.
Right.
So essentially, everybody who has a ground all throughout Omaha and the surrounding metropolitan area, they don't have grounds.
Right.
And the air base has suffered from this thing with water tables dropping and stuff. You have to put a 100-foot ground rod, a 5/8 inch stainless steel compression coupling device. You got to pound it into the ground, literally with a hammer.
Well, let me add then.
Yeah.
Let me add that I have wire mesh. It cost me a fortune. I have wire mesh about 2 inches under the ground, all the way around, directly under the antenna. That wire mesh is attached to 2 water wells that go down in excess of 150 feet, right into the water.
Okay.
So
How far are the water wells apart from each other?
300
feet apart?
About a little more than that, I would say.
Okay.
But close.
Well, the purple plasma that you're seeing up there, you got solar winds coming. That's the flux transfer coming into the atmosphere.
Uh-huh.
And on certain occasions, when you get an overage of over 300 kilometers per second, you're going to see this stuff penetrate through the magnetosphere of the Earth. About every 8 minutes, this thing opens up and allows all this extra plasma to come in.
All right.
And
Doctor, hold on.
Yeah.
Stand by. We're at a break point. There's never going to be enough time in this show. I'm Art Bell, and this is amazing stuff.
Just trying to decide. I'll stay by
Want to take a ride? Your conductor, Art Bell, will punch your ticket when you call 1-952-CALL-ART. That's 1-952-225-5278.
You're definitely on a ride. Professor David Paris is my guest, and we've definitely been rocking it tonight. No question about it. Professor, welcome back. Actually,
Thank you.
how long have you been working on this aspect of this project?
3.5 years.
3.5 years. So
Yeah.
a lot of thinking before it, right?
No, yeah, about 9 years before that as well. You know, I mean, it's been ever ongoing since 16 years old. Picked it up, let it down. At that time I didn't have enough knowledge to. I comprehended what I saw, but I didn't have enough technical knowledge on how do I turn that into something.
So it was really these aircraft anomalies that gave you the push.
Yeah, that was the impetus behind everything, of the detective story of
Sure.
correlating meteorological effects, space effects, electrical energy transferring back and forth,
Right,
bidirectional flow of energy from ground to space, space to ground.
right.
All of this was involved in that. And then the subsequent discovery of reading some other papers of the tripole field structure within the clouds and antimatter gave all the various pieces of the puzzle to put together, at least from my perspective, that paralleled Alcubierre's theoretical projections of what space warp would be, what it would look like, and the manifestation of how it would occur. And that's been the whole big bugaboo about all of this, is all these other teams trying to figure out how do you artificially engage in warp space.
Right.
It was non-sustainable from a thunderstorm, but given that concept, of the internal structures. That's where it led me to develop these fractal arrays, or initially these antennas that simulated what happened inside the thunderstorms.
Mm-hmm.
And I would also add that a banner day of when we had our first success of actually sensing the warping of space, October 15th at 6:15 p.m. I remember that date specifically because that was the date my brother called me. And we had a long conversation. He goes, "You did what?" And he's 4 years older than me, and he was always the guy punching me in the arm. You know what I mean?
Yeah, sure.
As always the little the little kid, and tagging along. Get away, Anyway, but that was a banner day of October 15th at 6:15 p.m. and that's when we had our first positive results. So,
well, let that be in the history books. William, you're on the air with Professor Paris. Hi.
Yes. Hey, Art. Hey, Professor. How you doing?
good.
I was wondering, I have a question, too, if I may, about commercial applications.
Yes.
What if you develop this for airlines and you start having many planes or vehicles flying with it? How would this redefine the role of the air traffic controller? How would they track it? And is there a chance of a collision with that?
Well, personally, I would envision, at least in the beginning, before more sophisticated systems evolved, I'm not talking about the warp drive, but I'm talking about how to handle this thing, is that we would have air navigation lanes like we used to before going from point A to B, airport to airport. So we'd have specific air corridors where you would go one direction. I mean, it would be as simple as that, I believe, to go from East Coast to Europe. And then a return corridor that's totally separate, and nothing else would be allowed to fly in those corridors.
Okay, my last question, sir, would be, what if you had a technical malfunction inside the bubble? Would you just simply wink out of existence or crash out of the bubble? What do you think might happen?
This is why, if you have looked on our website and to the Facebook, the Bluebird is actually a high bypass lifting body, and this craft, if that something catastrophic like that occurred, power failure, whatever, this thing would still glide. You could still fly it. And if you wanted to put auxiliary engines, that's why, see, we're a proponent for adapting to repurpose craft. So you wouldn't have to destroy a 777 and redo it all. You put these pods on here, and then you would then configure the warp field, but you would still be able to then disengage at altitude the warp and then land conventionally at an airport, and you would save, probably up to 600,000 pounds worth of fuel, and only have to utilize maybe 350 gallons of fuel to take off and land.
Oh, thank you. Excellent show, Art. Thank you.
Right, thank you, and take care. Let's go here. I don't know, to the phone. Hi, you're on the air.
Hi, Art. Thank you for taking my call, and a quick shout out to my friends who are listening. I wanted to thank the professor for his courage in the face of adversity, and hopefully in the future it's going to serve as inspiration. And I just have two brief questions.
Sure.
Thank you. First, would you be able to discuss any similarities to EagleWorks research into the M Drive or possible funding from them, or your reactions to their results? And second, just to satisfy my own curiosity, because it's rare that I can speak to someone of your stature, do you have any thoughts on the theory that the universe could be a simulation? Thank you very much, Art. And thank you to the professor.
Right.
Well, let's start with the simulation. I can only report that it feels like reality to me. So I think that kind of takes care of that one. I see it as what it is, as mass moving around, and we keep learning more and more as the days go on. That would be really scary to think that this is all like the Matrix or something, right? And the other question, let's see, that was in context to.
He's gone. Sorry about that.
Let me just think here for just a second here. What he was. In relationship to EagleWorks and what they're doing out there. what they've actually done using the EM drive, and this is NASA Houston and Dr. Harold Sonny White's team, they've explored the internal workings of the basically the chamber which they bounce microwaves around. Mm-hmm. They have heating issues with that, and they have to readjust and retune this thing a lot. Now, what they discovered with the warp bubble, and they also ran this in a vacuum. So it runs in a vacuum, runs in space, it runs in the atmosphere. It's very low level as far as the amount of newtons that it produces, but I guess that could be boosted up with increased energy. But the bottom line is what they have inadvertently done is kind of vetted our conclusions over here is that they detected the warp bubble inside. Now, I don't know to what descriptions that they've got that, but they have indicated, at least in the press, that they discovered a warp bubble association with bouncing these microwaves inside of their EM drive by the Shire drive, actually. He's an engineer scientist out of England that built this back in 2001. And people discredited him and told him that, it doesn't work, can't work. And now NASA's proved that it does work. And so now they're interested in the thing. They built one themselves. So that relationship of these other teams are out there. They're all going for the golden ring to pull it. And, we can't look behind. We got to keep moving forward. And because we have limited funding, it's whatever I can earn, and put into this project. And we stretch every dollar.
Well, it sounds like that gold ring is about to get yanked.
I really hope that we are the first team that comes in and can produce this satisfying vision of the craft lifting off the ground.
Of course.
I can't afford to build the Starship Enterprise. Now, other people have rendered it in picture form. Of the new Starship Enterprise or USS Enterprise. I can't afford to do those kind of things. I have to put my stuff into the hardware and into the software development and that. So, we're always going at 1,000 miles per hour in a sense of trying to accomplish this thing, get this thing to fruition. Because we know that if we sit to the sideline for any given amount of time, we're going to get overtaken by somebody. What is your goal, Professor, by going public, by being on shows like this? Well, there's been a lot of discussion of how do you hide things right in public view. Well, yeah. I mean, the bottom line here is I don't have a lot. Somebody comes and they take this away. There are going to be a lot of people that know that this project was here. And I am not going to be shut down in that sense. I'm not going to be closed down because I'm just going to stand up and say how it is.
I thought that might be your answer. All right. Hello there. You're on the air.
Hey, Art. How you doing, Professor? This is Torch. How you doing? Did you get my email today? I got a few questions.
I don't know who are you talking to.
Torch. Both of you.
No.
I sent you an email, but
anyway, if you have a question, go ahead.
Yeah, basically what you're building is a plasma drive, right? And I was just curious what you're building the Bluebird 2 out of.
Well, he spent the whole show explaining that as much as he could.
Yeah, well, I guess he's using composites then, right? Or carbon fiber?
It's not a plasma drive. Okay, right. That's the EM drive guys over there in Eagle Works in Houston. Ours is what we can determine at this point with all the results that we have that it is a warp drive. It alters the fabric of space. Now, as far as the materials that the Bluebird is made out of, it's 063 materials, aluminum, T6 that we use for the bulkheads, and we skin it with the 023 aluminum T6. It's weldable, but we don't weld it, we rivet everything. Mm-hmm. So there's like thousands of hours that's gone into that thing to put all this together, but our whole idea and concept has been to keep it as light as possible so that due to our power limitations that we need to overcome the so many newtons for so much weight. And this is what was encouraging with our new predicted line graph, is that with our current power capabilities, well, in the next month or so, that when we go up to from 2,000 to 4,000 watts, this is where we have the break point that now we can do some serious stuff, serious lifting with this.
All right, JC12 or 1520, you're on the air.
Hello, Art.
Hello, get close to your mic, please.
Yes, I'm trying to.
Okay.
Am I having any feedback?
You're okay. Go ahead.
I'm okay? All right. I really appreciate the discussion tonight.
Good. Do you have a question?
Yes, I do have a question. When you're talking about these kinds of technologies, there's this lingering question that I've heard from many other scientists that there's a delta T involved. There's a change in time that when you use these 0 point energies or whatever you want to call them, that you might be speeding up time around the area that you're using those technologies, and that might actually speed up the time that the sun has the ability to use energy, that we're speeding up the time of energy in the sun, that it might burn out.
Boy, I don't know about that.
Too quickly. Well, it's just this delta T concept is that we're speeding up time around the local area, and that might burn out the sun too quickly, and that might be a very obviously, you know what I mean.
Not a bad thing. Yeah, burning out the sun would be a bad thing. But I think the question about time is nevertheless a good one.
Yes, it is, and we have run time experiments with our mechanical stopwatches, because you get into the fields that are generated from this thing. If it's a circuit, it can destroy circuits if it's out in front of this
I would think, yes.
And so we have taken actual mechanical stopwatches and have a control. We have multiple stopwatches, and we go into the Faraday cage and position the watch in all different locations. Have the control watch outside. We take photos of it, digital photos, and then we make comparisons afterwards. And there's no differential of time. Now, Alcubierre also predicted that within the warp bubble itself, an observer from the ground, their ground clock would match identically to the clock within the craft itself. So there is no time distortion with this thing. Now, you may find a time differential in the actual line of the compression field itself, where the fabric of space has been warped. You may find a time differential there, but it has no effect onto the overall bubble itself, because it then expands out and everything goes back to normal there. All right. We have analyzed that, and we don't see any of the discrepancies. And also, Gurnon's flight, there wasn't any time discrepancy between the clock towers and his aircraft clock.
Gotcha. All right. So if they're small or not able to measure it at this point, you're on the air. Hello?
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 I've got a question for David.
Yes.
The fact is, the time might be a differential along the line of compression, and possibly you could get a gain in by altering the speed of light. Have you thought about putting this thing near a Wilson cloud chamber and see what effect it has on the particles that are displayed in there?
It's a good idea. I got a Wilson cloud chamber in the lab. We just haven't had that kind of luxury of time to play around with that kind of stuff. I get a lot of suggestions through emails that are posted to our website, and they're all very interesting, except I have to maintain my focus to get to the end goal here, and that's to get this thing off the ground. And I would be more than happy is when I have adequate funding from selling this device is to hire a whole team of engineers and scientists to analyze all the backfill, in other words, of all the other potentials of what happens and really narrow this thing down and be extremely specific. Now, I don't want to give the impression that we're moving ahead so quickly that we're not considering biologic factors here. We have and we do, and that's why we have a level of safety in our lab to protect ourselves from anything that goes on within the chamber itself.
All right, Professor, I've got to stop you there because the show is ending. I mean, I don't know where it went. It's ending. So, two things. One, incredible what you've said tonight. Two, I need to have you back. We could do shows on this and any number of other subjects. So, will you come back again, please?
Oh, absolutely. I thoroughly enjoyed talking with you and to the audience as well. It's for me, this is kind of like a little vacation. It's relaxing.
Well, as you can see, they're a pretty bright bunch. They really are.
Yes.
All right, Professor, thank you. We'll be talking to you actually very soon. Thank you.
Okay.
Good night, my friend, and good luck. All right, tomorrow night, some form of open lines. I'm thinking about it. I'm mulling it over. But it'll be open lines. Tomorrow's Friday, and I just have fun on Fridays. But this, this was a blast. Good night.